Good day, sir. Good day, classmates. So today I'll be talking about regression curve. A regression curve is a smooth curve fitted to the set of paired data in regression analysis. For linear regression, the curve is a straight line. So now I'm going to discuss about the things that you need to learn about regression curve. First thing is regression analysis. Regression analysis models the relationships between a response variable and one or more predictor variables. Use a regression model to understand how changes in the predictor values are associated with changes in the response mean. You can also use regression to make predictions based on the values of the predictors. Next is curve fitting using linear and nonlinear regression. In regression analysis, curve fitting is the process of specifying the model that provides the best fit to the specific curves in your dataset. Curve relationships between variables are not as straightforward to fit and interpret as linear relationships. For linear relationships, as you increase the independent variable by one unit, the mean of the dependent variable always changes by a specific amount. This relationship holds regardless of where you are in the observation space. So unfortunately, the real world isn't always nice and neat like this. Sometimes your data have curved relationships between variables. In a curved relationship, the changes in the dependent variable associated with one unit shift in the independent variable varies based on the location in the observation space. In other words, the effect of the independent variable is not a constant value. So now that we've got the basics down, I'm going to discuss on why you need to fit curves in a regression model. So the fitted line plot below illustrates the problem of using a linear relationship to a fit curved relationship. The R squared is high, but the model is clearly inadequate. You need to do curve fitting. So here's the fitted line plot where the output is equal to 8.220 plus the input, which is 1.266. And where the S is 1.93253, the R squared is 84.0%, and the adjacent R squared is 82.2%. So when you have one individual variable, it's easy to see the curvature using a fitted line plot here. However, with multiple regression, curved relationships are not always so apparent. For these cases, residual plots are a key indicator for whether your model adequately captures a curved relationship. And if you see a pattern in the residual plots, your model doesn't provide an adequate fit for the data. A common reason is that your model incorrectly models the curvature. Plotting the residuals by each of your individual variables can help you locate the curved relationship. So that is all, and that's all you need to know about regression curve. Thank you, sir, and thank you, classmates. I am Federico Manuel Corte.
Good day, sir. I am Sean Stefano Loste, and today I'll be discussing about the law of total probability. So, what is the law of total probability? The law of total probability breaks up probability calculations into distinct parts. It's also used to find the probability of an event. So, for example, let's say we have event A. When we don't have enough probabilities for A's relationship to calculate it directly, instead we take a related event B and use that to calculate the probability of A. So the probability of A can be written as follows. Probability of A is equal to probability of A intersection of B plus probability of A intersection of complement of B. So this is what it looks like. probability of A intersection of B is equal to probability of A divided by B times probability of B plus probability of A intersection of complement of B is equal to probability of A divided by complement of B times probability of complement of B. So, in practical situations, it can be difficult to work with these equations. It's much easier to work with a tree or a table. So, let's have an example. Example, 80% of the people attend their doctor regularly. 35% of those people have no health problems the following year. Out of the 20% of people who don't see their doctor regularly, only 5% have no health issues during the following year. What is the probability a random person will have no health problems in the following year? So in step 1, in making a tree, we sketch out the tree itself. So first we make sure that our tree uses the data from our problem. So as you can see, 80% of the people from the problem sees a doctor. 35% of which have no issues, while 65% of these people have issues. Out of the 100% of people, 20% do not go to the doctor, and out of these people, 5% have no issues, while 95% have issues. Next is step 2. In step 2, we multiply the probabilities for each branch. So in the first branch, we have 0.8, and its following branch is 0.35 and 0.65. In the next branch, we have 0.2, 0.05, and 0.95. If we multiply 0.8 and 0.35, we will get 0.28. Multiply 0.8 and 0.65, we will get 0.52. 0.2 by 0.05, you will get 0.01. And lastly, 0.2 times 0.95, you will get 0.19 respectively. Lastly, we have step 3. We find the probabilities that answer the question. So, for our example, we want a random person that doesn't have health issues. So, that's 0.28 and 0.01. We add those both. And we have our answer. Thank you for listening. That is all.
So, hi guys, good morning. My name is Aika Miling. So, our lesson today is about mean of a random variable. So, what is a random variable? Random variable is a most possible value are numerical outcomes of a random exponent. And so what is the types of a random variable? So a random variable usually write x, like what I said earlier. So it's a variable whose possible values of numerical outcomes of a random phenomenon. So there are two types of a random variable. It's discrete and continuous. And here the example of a random variable. So those second coin, we should get heads 0 and tails 1, and we have random variable x. So random variable is x, and the possible value is 0, 1 because the tail and the heads are 0 and 1. So the random events is head and tail. So in short, x equals 0, 1. So thank you.
Good day, everyone. My name is Dave Franco S. Espino, and I'm here to discuss probability axioms. So chance is a slippery concept. We all know that some random events are more likely to occur than others. But how do you quantify such differences? How do you work out the probability of, say, rolling a 6 on a die? And what does it mean to say the probability is 1/6? Mathematicians avoid these tricky questions by defining the probability of an event mathematically without going into its deeper meaning. At the heart of this definition are three conditions called the axioms of probability theory. So the first one is axiom 1. So axiom 1, the probability of one event is a real number greater than 0 to 0. Axiom 2, the probability of an event that at least one of all the possible outcomes of a process, such as rolling a die, will occur 1. Axiom 3, if two events A and B are mutually exclusive, then the probability of either A or B occurring is the probability of A occurring plus the probability of B occurring. So example, in a presidential election, there are 4 candidates. We call them A, B, C, and D. Based on our polling analysis, we estimate that A has a 20% chance of winning the election, while B has a 40% chance of winning. What is the probability that A or B? Notice that the events that A wins, B wins, C wins, and D wins are disjoint, since more than one of them cannot occur at the same time. For example, the third axiom of probability. The probability of the union of two disjoint events is the summation of an individual probability. Therefore, P of A wins that will be all.
So, good day everyone. So, my name is Yarrow. So today, I'm going to talk about probability density function. So, do you have any idea what is probability density function? Anyone? No? Okay. So, probability density function. So, a function of a continuous random variable whose integral across an interval gives the probability that the value of the variable lies within the same interval. So to get a feeling for PDF or probability density function, consider a continuous random variable x and define the function f of x as follows. So here's the formula of the probability density function. So f of x is equals to limit of delta as approaches O to the right, p of x is less than x but as less than or equal to x plus delta over delta. So remember that the probability of x less than x as less than or equal to x plus delta is equals to f of x times x plus delta minus f of x of x. So we conclude that f of x is equals to limit as delta approaches O, f of x times x plus delta minus f of x over delta is equals to d f of x over d of x is equals to fx of x. So if f of x is differentiable at x. So here's an example of probability density function. So, but remember we have this. We have to consider a continuous random variable x with PDF f of x. We have number one, f of x is greater than or equal to 0 for all of x, or for all of elements of x of real numbers. So number 2. So the interval of negative infinity to positive infinity, f of x times u du is equals to 1. Number 3. The probability of x greater than a but less than or equal to b is equals to f of x of b minus f of x of a. So equals to the interval of a to b of f of x times u du. More generally, for a set A, the probability of all elements of x with respect to a is equal to interval of a f of x times u du. So here is our example. So let x be a continuous random variable with the following PDF. So f of x equals to ce raised to negative x 0 and as x greater than or equal to 0 otherwise. So where c is a positive constant. Letter A, find c. Letter B, find the CDF of x, f of x. Letter C, find the probability of x less than 1 but greater than 3. So, the solution. To find C, we can use the property number 2 above. So, it shows here that 1 is equals to interval of negative infinity to positive infinity, f of x times u times du is equals to interval of 0 to positive infinity ce raised to negative u du and equal to c times negative e raised to negative x as o approaches from o to positive infinity. So 1 is equal c is equal to 1. So letter B, find the CDF of x. So f of x is equal to interval of negative infinity to x, f of x times u du. So for x greater than o 0, we obtain f of x is equal to 0. So for x greater than or equal to 0, we have f of x is equals to interval of 0 to x as e raised to negative u du is equals to 1 minus e raised to negative x. Thus, f of x is equals to 1 minus e raised to negative x 0. Otherwise, x or greater than or equal to 0. So the third step is to find the probability of x greater than 1 but less than 3. So we can find the probability of x greater than 1 but less than 3 using either the CDF or the PDF. We can if we use PDF, we have probability of x greater than 1 but less than 3 is equals to interval from 1 to 3 f of x times t dt is equals to interval from 1 to 3 e raised to negative t dt is equals to e raised to negative 1 minus e raised to negative 3. So that is our topic about the probability and density function. That's all. Thank you.
Good day, sir. Good day, everyone. Today, I'm going to talk about mass probability function. Mass probability function is a function that gives the probability a discrete random variable that is exactly equal to some value. The probability mass function is often the primary means of defining a discrete probability distribution, and such functions exist for either scalar or multivariate random variables whose domain is discrete. So here's an example. Let your cube be defined as the number of heads if we flip a coin 2 times. So
can either be zero heads, one head, or two heads will appear. Mass probability function is just saying you want to know the probability of having one heads up. So the probability of having one heads up is Q equals 1. And this one is probability of having heads or tails plus the probability of having tails or heads. The probability of having heads or tails is 1/4 plus the probability of having tails or head is also 1/4. So the probability of having one heads up is 2/4 or 0.5. So now, you want to know what's the probability of having no heads. So P Q equals 0. So the probability is heads and tails and tails. So the probability of having tails and tails is equal to 1/4. And lastly, we want to know the probability of having two heads up. So P Q equals 2. The probability of having two heads up is heads and heads. And it is equal to 1/4. So now let's make a table. If we have 0Q, our probability is 1/4. If you have 1Q, our probability is 2/4. And if we have 2Q, our probability is 1/4. Now let's go to the basic definitions of mass probability function. Our first definition is f of qi should be greater than or equal to 0, and it must be negative. Our second rule is the summation of f q I from 1 to n, so is equal to 1. So let's try that our table. 1 is equal to f q1, this is q1, q2, q3 plus f q2 plus f q3. 1 equals 1/4 plus 2/4 plus 1/4. 1 equals 1. Our third rule is f of q I is equal 2Q equals QI. So this third definition sums up our mass probability function. That's all. Thank you.
So good morning everyone. My topic is about hypergeometric distribution. So in probability theory and statistics, hypergeometric distribution is a discrete probability distribution that describes the successes it draws without replacement, wherein each draw is either a success or a failure. So for example, 6 doctors and 90 nurses attend a small conference. All but 5 names are put in a hat and 5 names are randomly picked without replacement. So the clue in hypergeometric distribution is without replacement, meaning it is being removed and not putting it back. And the question is, what is the probability that 4 doctors and 1 nurse are picked? So the formula of hypergeometric distribution is this, in which n is 6 doctors are is 4 doctors, x is 1 nurse, capital N is 25, in which N is 6 doctors, R is 4 doctors, X is 1 nurse, and the capital N is 25 total, and the capital K is 5 names. So we will apply the formula now. So N is, we will just substitute. N is 6, R is 4, N is equal to 25 minus the number of N, which is 6. 25 minus the number of N, which is 6, and K is 5 minus R, which is 4, over the capital N, which is 25, and the capital K is 5. So 6, 4, 19, 1, 25, 5. If you apply the combination, the answer that you will get is 15.19 over 53,130, and the answer is 0.00536. So this is the answer for the question, what is the probability that 4 doctors and 1 nurse are picked? So another example is, suppose a large urn contains 400 red marbles and 600 blue marbles. A random sample of 10 marbles is drawn without replacement. So here is the clue again, without replacement. So what is the probability? Exactly 3 are red. So if we apply the formula, N is equal to 400, which is the total number of red marbles, over 3, which is the red marbles in the question, and times 600, The meaning of without replacement is something being removed and not putting it back. And that is all.
Good day everyone. My topic is all about discrete random variables. What is discrete random variables? A discrete random variables are those variables who can attain countable discrete values such as 1, 2, 3, and 4. The probability distribution of discrete random variables gives the probability of getting each value of the random variable. For example, if a discrete random variable can attain values 1, 2, and 3, then the probability distribution will give the probabilities of getting the values 1, 2, and 3 for x. The cumulative distribution will give the probability of x getting a values less than a certain value. So, here is our problem number 1. 3 coins are tossed simultaneously. Find the value of the random variable for the number of tails obtained. So, solution. The outcome of a tossing a coin is head or H or tail or T. The sample space of the random experiment will be HHH, HHT, HTH, THH, TTH, THT, and HTT. The number tails obtained, x can be 0, 1, 2, and 3. So, it can be shown as the numbers under x is 0, 1, 2, and 3. So, since it is discrete variables, it has limit of from 0 to 3. So, events, so 0, HHH, 1, HHT, HTH, THH, 2, TTH, THT, HTT. Number 3 is only TTT. So here is the problem number 2. Let there be 5 boxes having 10 pins each. A box will be rejected by a retailer if it has more than 3 pins defected. Find the random variables and the values they can attain. Solution. There can be 2 random variables with the discrete values. So, x equals number of defective pens in packs. The values x can attain are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So, y equals number of defective boxes. Values y can attain are 0, 1, 2, 3, 4, and 5. So that is all for my discussion. Thank you.
Good day everyone. Today we're going to discuss about the Bayes theorem. So, the Bayes theorem, also known as the Bayes rule or the Bayes law, is named after the English minister and mathematician Reverend Thomas Bayes. So, it is used to describe the probability of an event to occur based on prior knowledge on the conditions that might be related to the event. For example, if cancer is related to age, then by using Bayes theorem, a person's age can be used to discuss the probability that they have cancer. So, we are given the equation, the probability of A given B is equals to the probability of A and B all over the probability of B. And the second equation is the probability of B given A is equals to the probability of B and A all over the probability A. So we will simplify the equation. So this will be equal to the probability of A given B times the probability of B. And we will assume that since probability of A and B and probability of B and A are both equal. So next is we will simplify this, so it will be equal to the probability of B given A times the probability of A. So to simplify, let's divide this by the probability of B. So cancel this out. So we are now left with the equation, the probability of A given B is equals to the probability of B given A times the probability of A all over the probability of B. So this is now the equation that we will be using for the basic theorem. So now let's have an example. So let's assume that we are given these values. So for the values of A, we have a set of numbers 1, 2, 3, 4, and 5. So for B, we have values 4, 5, 6, 7, 8, and 9. So now we will look for the probability of A. So the probability of A, since we have 5 data in the 9 datas in a set, so it will be equal to 5 out of 9. So next is the probability of B, which is equal to, since we have 2, 4, 6 values of B, 6 values of B out of 9 values. So we have 6 out of 9. So next, we will be looking for the probability of B given A. So the probability of B given A. So we can take a look at this. So 4 and 5. So given that 4 and 5 occurred twice in the set A out of 5 data, so it will be equal to 2 out of 5. Now we will substitute it to that equation. So we have the probability of A given B is equals to the probability of B given A is equals to 2/5 over 5 times the probability of A, which is 5 over 9, all over the probability of B, which is 6 over 9. So we can cancel this out, 1, and we can have an answer of 1/3. So that is the probability that is the answer for our first example. Now we will go to the second way of finding the probability of this set. So we will use the original equation, which is the probability of A given B is equals to the probability of A and B all over the probability of B. So the probability of A and B is equals to A and B is equals to 2 out of 9 or 2 over 9, since there are 2 data that occurred twice in the data given. So probability of A is equals to 2 over 9 all over the probability of B, which is 6 over 9. So originally the answer would be 2 out of 6, and it will be equal to 1/3. So that's all. Thank you.
Good morning, everyone. Today I am here to talk about statistical experiment.
statistical experiment is a random experiment. All statistical experiments has three things in common. First, all statistical experiments has three things in common. First, the experiment has more than one outcome. Second, the outcome is specified in advance. Third, the possible outcome depends on chance. For example, a coin toss has all the attributes of a statistical experiment. There is more than one possible outcome. We can specify each possible outcome by asking heads or tails in advance. And there is an element of chance since the outcome is uncertain. A sample space is
Go.
sample space is a set of elements that represents space sample is a set of elements that represents the possible outcome of the experiment. There are two types of sample space: sample point and event. Sample point is an element sample point is an element of the experiment, and event is a subject. And then event is a subject of the experiment. Probability of an event. With some statistical experiments and each sample point is equally likely to occur. In this situation, the probability of an event is very easy to compute. The formula is P of E equals to the number of sample points in event over number of sample points in sample size. Events mutually exclusive if they have no sample points in common. Independent when the occurrence of one does not affect probability of the other occurrence of the other. That's all.
Another branch of statistics is the law of iterated expectation. The law of iterated expectation states that the expected value of a random variable is equal to the sum of the expected values of that random variable conditioned on a random variable or assigned random variable. So, in other words, the expected outcome of an event can be calculated using casework on the outcomes of the event it depends on. For instance, the probability of rain tomorrow, given that it will rain today or it will not rain today. To have it in numbers, the probability of rain today is at 70%. Now, if it rains today, the probability of rain tomorrow will be 30%. However, if it does not rain today, the probability of rain tomorrow will be at 90%. So, to calculate it all, the probability of rain tomorrow will be the probability of rain today times the probability of if it rains today, what will be the probability of tomorrow? It will be 30. So times 0.30. Plus, if it rains today, what is the probability of rain tomorrow? Again, 30%. Plus, times, if it does not rain today, what will be the probability of rain tomorrow? It will be 90%, as I said lately. So, sum them up. The probability of this will be equal to 0.21 and this is equal to 0.28. It will be 48% and this will be your probability of rain tomorrow, given that if it rains today and it does not rain today. So, another example is a player scores 2 points 80% of the time when he is guarded. However, only scores 40% of the time when he is, 80% of the time when unguarded and 40% of the time when guarded. Now, while they are playing, this player will be guarded 70% of the time. What are the probabilities that he will score this point? Again. So, basketball player, the points that he scored, is equal to the points that he scored times the probability that he scored when guarded when guarded will be 70%. Plus the probability of the player when he scored times when he is unguarded plus multiplied by when he is unguarded. It will be at 0.3. Why 0.3? Because 70% of the time he is guarded. The remaining 30% meaning he is unguarded. So, multiply this. 2 times 0.4 2 times 0.4 times 0.7 will be at 0.56 plus plus 2 times 0.8 times 0.3 will be at 0.48. So, the probability that this player will score 2 points of the game will be at 0.56, the summation of this 0.56 plus 0.48 will be at 1.04%. the formula will be let x and y be random variables, then y is equal to the probabilities of A and this one, where xy is the conditional probability of distribution of the x given the probability of y. Now, all of this is how you do the law of iterated expectation. Again, but here's a tip. In life, what you expect, according to Erickson, will be really in his book that what you expect that will happen will actually will. That's all. Thank you.
So, hello, good day everyone. For today, I will be discussing about probability distribution for discrete random variable. So we have here a given sample experiment. There are 3 defective motherboards in a package of 10. 2 are randomly selected without replacement. Find the probability distribution for the variable x, which represents the number of defective motherboards selected. So, first step is to analyze the sample experiment. In here, we can easily conclude that the most value of x that it will get is 2, since we will only have 2 chances to randomly select an effective motherboard without replacement. So we'll put it this way. P equals x equals to 0, x equals to 1, and p x equals to 2. Now for the first one, when p x equals to 0, the probability to get a non-defective motherboard. So we have in a package of 10, there are 3 defective motherboards. 10 minus 3, we have 7 over 10. And now, since we have 2 chances that we can randomly select, we will now use our second. So 10 minus 1, we have 9, and 7 minus 1 is 6. So 7 times 6, we have 42, 10 times 9 is 90. Next is for our p x equals to 2, with the probability that we will get both defective motherboard. So there are 3 defective motherboards, 3 over 10 times 2 over 9. So 3 times 2, we have 6, and 10 times 9 equals to 90. And px equals to 1, this is the most critical part, since we do not know if we will first get a defective motherboard, or the second we will get an undefective motherboard. So we will just put here simply how a probability distribution goes. So probability distribution applies all the possibility, all the possible outcomes. So we have to add our p x equals to 1, which is 42 over 90, and our p x equals to 2, which is 6 over 90. So we will put it in 1 minus 42 over 90 plus 6 over 90 is 48 over 90. 1 minus 48 over 90, we have 42 over 90. So this probability x equals 1. Now, to put it in the table, if our x is 0, 1, and 2, our probability of x 0 was 0.47, 1 is 0.47 also, and R2 0.07. Now, we can also get the expected value of the given sample by using this formula. So, expected value of x, summation of x times p times x. So, the first is 0. We have 0.47. 0 times 0.47 plus 1. R1 is 0.47 also, plus 1 times 0.47 plus 2 times 0.07. So 0 times 0.47, 0. So 1 times 0.47, we have 0.47. 2 times 0.07, 0.14. So 0.47 plus 0.14, our expected value in the given sample, experiment sample is 0.61. So that's how it goes for the probability distribution for discrete random variable. When our x non-defective, we will get 0.47. When it is 1, 0.47, and we will get 2, the probability we will get both defective motherboard is 0.07. And our expected value, by using this formula, we can attain accumulated value of 0.61 as our expected value. That's all, and thank you very much for listening.
Good afternoon. I'll be talking about conditional probability. Conditional probability is the probability of one event occurring with some relationship to one or more other events. In probability theory, conditional probability is a measure of the probability of an event, some particular situation occurring, given that another event has occurred. So here I have an example. A math teacher gave her class 2 tests. 25% of the class passed both tests, and 42% of the class passed the first test. What percent of those who passed the first test also passed the second test? The analysis here is the problem described conditional probability, since it asks us to find the probability that the second test was passed in the last lesson, the first test was passed in the last lesson. The notation for conditional probability was used in the statement of multiplication 2. Multiplication rule 2 is when two events A and B are dependent. The probability of both occurring is P A and B equals PA times P, B, and A. The formula for this conditional probability of an event can be derived from multiplication rule 2 as follows. In order to solve this problem, step 1 is to start with multiplication rule 2. Then step 2 is to divide both sides in the equation PA. Step 3, cancel the PA's on the right hand side of the equation. Step 4, you have to divide P and B equals over P and A equals P, B, and A. So here you have to commit the equations. Now we can use this formula to solve the problem earlier. That's all. Thank you.
Good day, sir. My topic to be discussed for today is triangular distributions. Triangular distribution has a definite upper and lower limit, so we avoided extreme values. In addition, the triangular distribution is a good model for skewed distributions, just like this. All probability density functions of triangular distribution have property that the area under the function is 1. For the triangular distribution, the property implies that the maximum value of the probability distribution function is 2 over b minus a. It occurs at the value of c.
Go.
So triangular distributions is a continuous probability distribution with a probability density function shaped like a triangle. So this is how it looks like. So this is a real life situation. We can often estimate the maximum and minimum values even if we don't know the mean and standard deviation. The formula of probability density function is f of x times 2 times x minus a over b minus a c minus a. 2 times b minus x over b minus a times b minus c. So here's an example. A burger franchise planning a new outlet in Manila. Triangular distribution to model the future weekly sales.
they estimate that the minimum weekly sales of one is 1,000 and the maximum is 6,000 pesos. So they use A is into 1,000, B is to 6,000, and C is to 3,000. The graph of the probability density function reaches its maximum of 0.0004 and C is to 3,500. The graph is shown below. So here's the graph. So that's all. Thank you.
So, good morning everyone. I'm going to discuss about Bernoulli distribution. So, for example, we toss a pair coin once. What is the distribution of the number of heads in that single toss? Suppose we have a single trial, and in each trial can result to one of two possible mutually exclusive outcomes that we will label as success or failure. So, the probability of success will be represented by P, and the probability of failure will be represented by 1 minus P. We're gonna let the random variable x be equal to 1 if success occurs and x is equal to 0 if failure. So if these conditions hold, we will have a Bernoulli distribution. So where the probability of the random variable x can take is equal to p to the x times 1 minus p to the 1 minus x. So we have x values which are 1 or 0. And if we were to write this in an individual value, we have the probability is equal to 1 times 1 minus and p probability of x equals to 0. This will be the probability of success and the probability of failure that we talked about earlier. So here's another example. So, approximately 1 in 200 American adults are lawyers. 1 American adult is randomly selected. So, you might ask yourself, what is the distribution of the number of lawyers, or they are not? So here we have a single trial in each person that is a lawyer, or they are not. So in this, the conditions of the Bernoulli distribution are satisfied. So the number of lawyers will have a Bernoulli distribution with a parameter p equal to 1 over 200, which is any one individual that is a lawyer or not. So be the number of wires. So the probability of any random variable x is equal to the p, which is 1/200 to the x times 1 minus 1/200 to 1 minus x. So you will take the values of x, which are 1 and 0. So the probability that we will get one wire is 1/200, and the probability that we will not get any wire will be 199/200.
Today I will be talking about geometric probability. It is a tool that is used in dealing with problems with infinite outcomes. So there are three types of this: one-dimensional, two-dimensional, and three-dimensional. So today I'll give you the problem. Your class is coming at a random time to solve at 1 p.m. If you arrive at exactly 12:30, how likely are you to catch the bus? So we will draw a graph, a line. Okay. So at this point, this will be 1 p.m. 12. The spectrum is 12:30 p.m. So yeah. So how far is 12:30 to 1? It's exactly 30 units apart or minutes. And from 12 to 12:30 is still exactly 12 minutes. So how likely are you to catch the bus? So the number of outcomes, your desired outcomes could be exactly 1 or 30 minutes and time for your desired outcome over a total number of appropriate outcomes. 60 and 60 minutes. In 60 minutes, you only have 30 minutes to catch your bus. So divided by it would be 1/2. So how likely are you going to catch the bus? Exactly 50%. The previous example is an example of a one-dimensional geometric probability problem. Okay? So I will now be talking about another example of a two-dimensional geometric probability problem. So, door is thrown at a circle. Such that it will randomly over the area of the north or okay? So the problem is a dart is thrown with a circular dartboard such that it will land randomly over the area of the dart. What is the probability of the dart landing closer to the center rather than to the edge? Okay, so let's use that. So first, this particular report, this is the center, this is the edge. So how can this be closer? So first, this would be the radius. So half the radius, less than or 1/2 or would be closer to the center. Am I right? Yes. So yeah. So first we need to find the area. We hold the dartboard. So this would be the total outcomes we desire, and this would be the outcomes we must. So the area of the dartboard would be equals to pi r squared. And the area of our what we want our desired outcomes would be equal to pi r over 2 squared. So we will divide 2. It will be pi r squared over 4 over 5 r squared. So pi r squared can be cancelled out. So it will be equal to 1/4 or 85%. So the probability of the dart landing closer to the edge rather than the edge would be 85%.
So, good morning everyone. I am Libert Tawarka. So for today, I will be discussing a short introduction about probability. So anyone who has an idea here about probability? Okay. So probability is a study of chance or a likelihood of an event happening directly or indirectly. Probability plays a role in all activities. For example, we may say that it would probably rain because we have observed it was raining for the most of the days. However, in mathematics, we would require a more accurate way of measuring probability. So here, okay. So in other words, probability is a science of how likely events are to happen. At its simplest, probability, it is concerned in the roll of a dice or a fall of a card in a game. But probability is vital in science and life more generally. So, for example, in diverse areas, probability is used for weather forecasting and to work out the cost of insurance premiums. And basically to understand probability,
we're going to throw a standard dice, and then you want to know your chances are for throwing number 6. In this case, there is only one outcome that will lead to that event. For example, you throw number 6, and the possible outcomes altogether is just 1, 2, 3, 4, 5, and 6. So therefore, the probability of throwing 6 is just 1/3.
So an event that is certain to occur has a probability of 1 or 100%. One that will definitely not occur has a probability of 0. And then it is also said to be impossible. So that is my short introduction about probability. Thank you. Now suppose that you want to know your chances are for throwing 1 and 6. There are two favorable outcomes, which is 1 and 6. But still, the outcome is 6. So therefore, the probability is just 2/6. And then you can reduce it by or into 1/3. So that's my short introduction about my topic, which is the probability. Again, I'm Libert Tawarka. Thank you.
So good day everyone. Now we are going to talk about binomial distribution. Now binomial distribution is the probability distribution of a binomial random variable. Now a binomial random variable is the number of successes x in n repeated trials in a binomial experiment. Now, before we go further or further explore what is a binomial distribution, we should discuss first what is a binomial experiment. Now, in a binomial experiment, it is actually a statistical experiment that consists of n repeated trials, and each trial can only result to two possible outcomes. One of these outcomes, we can say that it's a success, and the other one is a failure. Now, the P, which is actually the possibility of success, is the same in every trial. And lastly is the trials are independent. That means that the outcome of one of these trials doesn't affect the outcome of other trials. Next. Okay, now let's go to notations. Now, X is the number of successes that results from the binomial experiment. And N is the number of trials in a binomial experiment. P is the probability of success. Then Q is the probability of failure in an individual trial. This is equals to the quantity 1 minus P. Then N factorial is the factorial of N. Then B, X, and P is the binomial probability. And NCR is the combinations of N taken R at a time. Now, here in our binomial distribution, for example, on an instance, we flip a coin 2 times and count the number of heads or successes. Now, the binomial random variable is the number of heads that can take by 0, 1, and 2. Now, this is our binomial distribution if we flip a coin 2 times. Now, this is the number of heads, which is 0. Now, its probability is 0.25. Now, number of heads, 1. Then its probability is 0.50. Then number of heads, 2. 0.25 probability. This is equal to 25%, 50%, and another 25%. Now, there are 3 properties of a binomial distribution. First is the mean of the distribution is equal to N times P. Second property of a binomial distribution is the variance is equal to N times P times the quantity 1 minus P. Then the third and last property of a binomial distribution is standard deviation is equal to the square root of your variance. And that is all for our binomial distribution.
Theoretical probability. So what is theoretical probability? We all combine all the possible outcomes are equally likely. So the theoretical probability is the ratio in the number of favorable outcome to the number of possible outcome. For example of theoretical probability. Choose one of the letters shown. What is the theoretical probability of choosing a vowel? So in the word explore, the vowels are E, O, and E. So the number of vowels are 3 and the total number of letters are 7. So 3 over 7 is the theoretical probability of vowels. So it means 43% is positive vowels. Yeah. So good morning. Today I'm going to tackle about the variance of random variables. So here we have the value of x and the probability. So this is the x1, x2, x3, and x infinity, and the probability 1, 2, 3, and to the infinity. So here we have the formula of the mean. Sometimes when you are solving some questions in the statistics, mean is also known the expected value of the
variance. And here we got the formula of the variance, which is summation of x1 minus the mean squared times probability. And the standard deviation, which is the square root of the variance. So this is my example. Gabby is a sales associate at large auto dealership. She motivates herself by using probability estimates of her sales for sunny Saturday in April. She estimates her car as follows. So this is her car sold. 0, 1, 2, and 3. The probability is 30%, 40%, 2%, and 1%. So we're going to use our formula for the mean, which is summation of x and summation of probability. And the formula for the variance, which is x1 minus mean squared times the probability. So this is how we're going to do it. We're all going to write the car sold in x1 and the probability here. To get the mean, we're just going to multiply the x1 and the probability. This is the answer, 0, 0.4, 0.4, and 0.3. To get the mean, we're going to add all the answers. The answer is we're going to minus our x1 and the mean. So 0 minus 1.1 times the probability, which is 0.3. It is equals to 363. And to get the answer of this, we're just gonna add the answers and we can get the variance.
Good day, sir. Good day, classmates. I'm here to discuss about the central limit theorem. It is defined that the central limit theorem is a statistical theory that if given sufficiently large sample size from a population with a definite level of variance, the mean of all samples from the same population will be approximately equal to the average of the population. So for example, this is the population, the normal distribution, and if it's like this is the average of the population. The central limit theorem states that when a finite number of successive random samples are taken from a population variation, the sample distribution of means of those samples will become approximately normally distributed, with means and sample standard deviation as the sample size becomes larger irrespective of the shape of the population distribution. So here's an example of the central limit theorem. On the right are shown the resulting frequency distribution of each based on 500 times, and the means computed each time. The same time which is allowed to reach with means of 7 scores to n equals 7 and 10 scores to n equals 10. So basically, in conclusion, the central limit theorem enables us to approximate the sampling distribution of x bar with a natural distribution. That is all from me, sir. Thank you for listening to my discussion, and thank you, classmates, and have a good day. Take this equation for example. From a population random variable that is distributed with a mean and standard deviation, do this repeatedly, drawing many samples from the population, then calculate the x of each sample. So, more than that, this is the 3 components of the central limit theorem. First one, successive sampling from a population. So, you're gonna successively sample the variables of a population to increase the accuracy. And then second, increasing the sample size. And the third, population distribution. So here's a second example. Dice are ideal for illustrating the central limit theorem. If you roll 6 side dice, the probability of rolling a 1 is 1/6. A 2 is also 1/6, and a 3 is also 1/6. As you know, this goes on until it reaches 6. The probability of the dice landing on any side is equal to the probability of landing on any side. So we can actually do this in a classroom experiment. We can carry out this experiment using an actual dice to get an accurate representation of the population distribution. Let's roll the dice 500 times. When we use a histogram to graph the dice, the distribution looks fairly flat. It's definitely not a normal distribution. So when the n increases, the distribution becomes more and more normal. The spread of the distributions decreases.
Good day, sir. Good day, classmates. I am Jaren Fructuoso, and today I'm going to talk about cumulative distribution function. So, what is a cumulative distribution function? A cumulative distribution function is a function whose value is the probability that a corresponding continuous random variable has a value less than or equal to the argument of the function. We have here an example. A random variable has probability density function f of x is equal to 1 for x, where x is less than or equal to 3, while x is greater than or equal to 1, while 0 here is otherwise. So we need to find f of x, which is the CDF. So here we will find f of x. So to find f of x, we must integrate first the given. So what we will have here is 1/4 is greater than 1 over f of x. And so we will start from the lowest limit, which is 1, and make x as your upper limit. So x is your upper limit, and 1 is your lower limit. So we will start from the lowest limit, which is 1, and make x as your upper limit. So we will take 1/4 outside of integration, which is equals to 1/4 integral of x, which is f of x from 1 to x, and we will have a value of 1/4 x squared from 1 to x. And then 1/4 times x squared over 2 minus 1/2. So we will distribute 1/4 to x squared minus 1 over 2, which we will get x squared minus 1 over 8, which is the CDF. So to prove that this function works, we will substitute 3 to the equation. So it equals to 3 squared minus 1 over 8, which is equals to 8 over 8, which then turn will equal to 1. So when our f of x is 0, our x is less than 1. If x is greater than 1 or equal to 1, and also less than or equal to 3, the equation is x squared minus 1 over 8, which is our CDF. And lastly, if x is greater than 3, our f of x is equal to 1. So that is all, sir. Thank you for listening, and till next time.
Placing we from 11 Yarrow, and discuss about the inverse Gaussian distribution and a short history about it. So inverse Gaussian distribution in probability theory, the inverse Gaussian distribution, also known as the Wall distribution, is a two-parameter family of continuous probability distribution with support on 0 and infinity. So the history, this distribution appears to have been first derived by Erwin Schrödinger in 1915 as time for passage of a Brownian motion. The name inverse Gaussian was proposed by Reading in 1945. So we have an example here, and it's f of x is lambda over 2 pi x cubed, and exponential lambda x minus mu squared over 2 mu squared and x. So the first step.
Today, we will talk about the probability of an event. Probability is a type of ratio where we compare how many times an outcome can occur compared to a possible outcome. So, equal to divided by probability is equal to the number of wanted outcome divided by the number of possible outcomes. So let's try to solve. Probability of getting all heads if you flip 3 coins. So let's try all the possible combinations. So first, these are the possible combinations. We can see that our favorable outcome is HHH or the triple heads. So our favorable outcome is 1. So and our possible outcome is 8. So 8. So our answer is 1/8. That's all.
I am Maria Nicole Piñaranda and I will be discussing about Chebyshev's theorem. So Chebyshev's theorem is the proportion of any distribution that lies within k standard deviation of the mean is at least 1 minus 1 over k squared, where k is any positive number greater than 1. So this theorem applies in any distribution of data. So, for example, this theorem says that within standard deviation of the mean, you will find at least 1 minus 1 over k squared, where k is equal to 2. So, 1 minus 1 over 2 squared is equal to 1 minus 1 over 4, and then 1 minus 1 over 4 is equal to 3/4. So 3/4 in decimal it is 0.75, and in percentage it is equal to 75%. So another example. Suppose that the average score on a math test is an 84 with a standard deviation of 4 points. According to Chebyshev's theorem, at least 1% of the test have a grade of at least 72 and at most 76. So the average or the mean is equal to 84. So our standard deviation is 4 points. So 84 plus 4 is 88. 88
80. And 80 minus 4 is 76. 76 minus 4 is equal to 72. So, our K here is 3 because 1, 2, 3. So, and 1, 2, 3. K is equal to 3. So, we will substitute this to this formula. So, 1 minus 1 over K squared, where K is equal to 3. 1 minus 1 over 3 squared is equal to 1 minus 1 over 9. Or we can write this as 9 over 9 minus 1 over 9 is equal to 8 over 9. 8 over 9 is equal to 0.89, or in percentage it is 89%. So that's all. Thank you.